Let's discuss designing wearable robots known as supernumerary robotic limbs for astronauts. So, looking at pre-existing wearables such as exoskeletons, they can directly augment pre-existing limbs on a human. Prosthetics replace lost ones, and supernumerary robotic limbs add additional ones which can create very unique use cases. In the context of astronauts, we can use things like external materials handling, gait assistance, and even performing some excavation. But the most important task for astronauts is recovering from a fall, as this requires high amounts in both dexterity and load-bearing capacity. Looking at this and studying it, we can see that astronauts take very prescribed paths as they stand up from a fall. This allows us to extract both the trajectory as well as endpoint loads needed from SuperLimbs. And we can parameterize the space looking at intrinsic parameters for designs, as well as extrinsic parameters for the designs, which gives a massive design feature tree to work with. If we filter this tree using functional requirements as heuristics and backtracking, we can then take those designs and rank them based off of energy consumption. That final design, we can then do a fine localized parameter search to get a final 4-DOF design shown here. Using human testing, we found a 55% reduction in load-bearing capacity, and we also found a very strong model-to-experiment match in our post-fall recovery experiments. Here are some of the limitations from both our experiment and our model. Thank you all very much.